This video has to do with finding vertical and horizontal asymptotes for a proper rational function. And by proper, we mean that the degree of the highest degree term on the top is less. In this problem, we have x to the first power. It is less than the highest degree of the denominator. In this case, it is x squared in the bottom. So that's a proper, just like a proper fraction, the numerator is smaller than the denominator. And in this case, a proper rational function is where the power on the top is smaller than the highest degree power on the bottom. Okay, so we're going to look at both the vertical and the horizontal asymptotes and how we find them. So we're going to go ahead and factor this, which isn't too difficult. We'd factor the top. There's a greatest common factor of 3, so that would come out as 3 times x minus 1. The bottom is the difference of squares, so that factors in the x minus 2 times x plus 2. And by the way, there's a lot of work already done on this sheet. We're not going to need it all to just do the asymptotes. We're going to need that later when we go and do a complete graph. And I have it worked out previous to the beginning of the video just so that it saves a little time on the video. Okay, but let's focus on getting the vertical asymptotes. So what happens is the vertical asymptotes are found from the factors of the denominator. Well, let's take a look and talk about the domain and how that is connected to why these factors really produce vertical asymptotes. It turns out in a rational function, which in a sense is a fraction, that as in any fractions are not allowed to divide by 0. So it turns out the values that would cause this denominator to go to 0 would be 2, because 2 minus 2 would be 0, or negative 2. So we have to eliminate those from the domain. So the domain also of rational functions is determined by the factors of the denominator. So it turns out if you set that denominator's factors to 0, you'd find that x equals 2 would be a factor that would cause the denominator to go to 0, and x plus 2 would cause x minus 2 to be a value that would cause the denominator to equal 0. So we would say that this domain of this function would be any real number except for 2 or negative 2. But if you started putting x values into this function that got really close to those values, while it wouldn't produce 0 in the bottom, it would get really close to it. And as you divide by a small number, you're going to produce a really big answer. And therefore, when you get near vertical asymptotes, the output is really big, either in the positive or negative direction. But let's just take a look here and draw these asymptotes. So the asymptotes are imaginary vertical lines at 2 and negative 2, the values that are not allowed in the domain. And so we're going to go ahead and draw those right here. And so at 2, and it makes sense, by the way, that a graph never crosses a vertical asymptote, because if it did, it'd be trying to put a value that would divide by 0 in the function. And no value could exist for that. No answer, no f of x or output could exist when you divide by 0. Okay, so and I'm drawing dotted lines because this is not part of the graph of the function. It's where the graph of the function is going to approach with really big answers or really small answers, right? And we'll worry about those specific values when we get to the video where we're actually trying to graph this same function. I'm going to go back through this function and do a full graph on a video titled Graphing a Function that is a proper fraction or a proper rational function. Okay, so the only other thing on this video we want to talk about is how do you find horizontal asymptotes on a proper rational function? Well, it turns out anytime this degree is smaller than this degree, if you started putting big values of x in here, for example, if I put 100 in here, this would be 300, but over 100 squared. It's going to end up tending to 0, because the bigger the value, the smaller the fraction, because this is getting squared in the bottom while this is only being multiplied by 3. So any proper rational function has a horizontal asymptote at 0. In other words, the x-axis is where this function will eventually follow. It's going to act like the x-axis, I'll draw a dotted line. I'm going to just draw it just above it. I mean, it really is the x-axis, but just to show you the horizontal asymptote there, I'm just trying to emphasize, maybe I'll extend it out a little bit, but it really should be the x-axis. That is true. Anytime you have a proper rational function, meaning the power on the top is smaller than the power on the bottom, eventually this function will end up out here. It'll either be right above 0 or right below 0 in both directions, right? So that's what we're expecting when we get to the video of actually graphing this function. But for right now, this is all we need. We just have finished the vertical and horizontal asymptotes of a proper rational function.